We are going to begin a new unit on writing chemical names and their corresponding formulas. This is in Chapter 9 of your chemistry text. Now, I want to begin with a very brief review of what you should already know. First, elements are the building blocks of all substances. There are about 90 naturally occurring elements. There are more on the periodic table, but about 30 of those are man-made. You take those 90 elements and you can make millions of combinations with them, millions of different compounds. Some atoms, such as the noble gases, exist all by themselves as isolated atoms, but most elements join together in compounds. All compounds are formed by chemical bonds. The bonds in compounds are either ionic, in which electrons are given and taken, or covalent, in which the electrons are shared. If the electrons are shared, the resulting compound is called a molecular compound. So in other words, if you have atoms joined by covalent bonds, then you have what we call a molecule. Molecular compounds are made of molecules, such as water. A molecule is the smallest electrically neutral unit of a covalently bonded substance that still has the chemical properties of the substance. If you remove any part of a molecule, you have a different molecule or not a molecule at all. Some compounds are ionic. They are composed of ions. If an atom gains or loses one or more electrons, it is no longer electrically neutral. It becomes an ion. Atoms of metals tend to form ions by losing one or more electrons. Such ions are called cations. I remember cation as being the positive ion by thinking of the T as a plus sign. The nonmetals tend to form ions by gaining one or more electrons. Such ions are called anions. The N in anion and the N in negative seem to be a good way for me to remember those two terms go together. So ionic compounds can form when cations are bonded to anions. They are electrically charged and attracted to each other. On your periodic table, you should have already written some of the expected ionic charges of what we call the representative groups. These are the elements that on the old style periodic table were marked with an A. So group 1A, which we now call group 1, seem to always form a +1 ion. Group 2A +2, group 3A, at least for boron and aluminum, is +3. We kind of skip over carbon and silicon and that group because those guys don't tend to form ions very readily until you get down to tin and lead. Tin and lead can have +2 or +4. Then we get to the nitrogen group, group 15 or 5A, they tend to form -3 ions. 16 -2, 17 -1, and group 18 do not form ions at all. Those are the noble gases. They have full or complete electron levels in their valence shell, and they do not need to gain or lose any electrons. I want you to add 3 more ions to your periodic table at this time. First, silver, Ag, is always going to be +1 for our course. Beside it, zinc and cadmium are always going to be +2. One more ion that you need to be aware of is the hydride ion. Hydrogen often loses an electron and becomes the hydrogen plus 1 ion. But sometimes it gains one electron, in which case it becomes a negative ion named hydride. You may want to write that somewhere on your periodic table as well. Compounds formed from ions, or ionic compounds, have to be electrically neutral. In other words, there has to be a balance between the number of positive and negative charges. Another way of saying that is there is a conservation of charge. If sodium gives its electron away, it has to give it to somebody. That somebody in the slide is chlorine. It gains one electron and takes on a negative 1 charge. Plus 1 minus 1 adds up to 0. So the formula unit is NaCl. But if sodium or chlorine had a different charge, plus 2 minus 2 plus 3 minus 3, there might be a different ratio, and that's one of the things we need to pay attention to in this particular lesson. Now, in reality, as we learned in our last unit, most bonds are somewhere in between ionic and covalent. But for the purposes of the present chapter, we're going to say if we have a metal and a nonmetal, or a metal and a polyatomic ion, then that's an ionic compound. And we're going to follow the rules for naming and writing according to the ionic rules. If we have two nonmetals, then we're going to say that's covalent. Those will be molecules, and we'll follow the names for molecular compounds. I've mentioned the word chemical formula several times, so let's make sure that we understand what we mean by that. A chemical formula shows the number and kinds of atoms in the smallest representative unit of the substance. For example, in a molecule, we have molecular formulas. In an ionic substance, we have what's called the formula unit. A molecular formula shows the number and kind of each atom in the molecule. Examples: H2O. There would be 1 oxygen and 2 hydrogens. In methane, there would be 1 carbon and 4 hydrogens. These are covalently bonded units. In ionic substances, the formula unit shows the lowest whole number ratio of ions. In other words, it shows what ratio is necessary in order for the substance to be neutral. For example, aluminum chloride, AlCl3, tells us that aluminum must have 3 times the charge of a chlorine, because you need 3 more chlorines, or you need 3 chlorines for every aluminum. Potassium oxide, on the other hand, you need 2 potassiums for every oxide ion. So oxygen must have twice the charge of potassium. For the remainder of the unit, we're going to focus on ionic compounds today. Later on, we'll take on molecular formulas in a separate lesson. So what you should be able to do after participating in this lesson is identify the charges of single ions, monatomic ions, by using the periodic table, and also apply the rules for naming and writing formulas for what we're going to call binary ionic compounds. In other words, ionic compounds that are made of just 2 elements. Now remember that a metal atom can transfer an electron to a nonmetal. For example, in the animation, you see sodium transferring an electron to fluorine. The sodium becomes positively charged, the fluorine becomes negatively charged, and they stick together because now opposite charges attract. The resulting cation and anion, in other words, are electrostatically attracted by forces known as Coulombic forces, and it forms what we call an ionic bond. So, compounds formed from cations and anions are referred to as ionic compounds. There's all sorts of ionic compounds, but among the most common that we are going to run into in this class would be those that are formed from the metals in the alkali metal group or the alkaline earth metal group, in other words, groups 1 and 2 on the periodic table, and those among the halides, the group 17 on our periodic table. Here are a few examples. NaCl, sodium chloride, has one sodium ion for every chloride ion. Calcium fluoride, on the other hand, has a 2-to-1 ratio. For every calcium, there are 2 fluoride ions. Lithium bromide is another 1-to-1 ratio of +1 lithium and -1 bromide ions. You'll note that all the compounds shown in the table are composed of just 2 elements. We will refer to this type of substance as a binary ionic compound. To name a binary ionic compound containing group 1 or 2 elements, keep the name of the positive ion as it is. For example, sodium stays sodium, aluminum stays aluminum. You do change the ending of the anion, the negative ion, to IDE. If you look back at the previous table, you'll note that chlorine became chloride, fluorine became fluoride, bromine became bromide. Here are a few other examples of ions and their names. This chart is not in your notes, but you should see that on the left-hand side, the positive ions have the same name as the element. You don't change them. The anion, on the other hand, always changes to IDE if it is a single atom. So O, oxygen, becomes oxide. Sulfur becomes sulfide. Please do note, as I said earlier, that sometimes hydrogen is a +1, in which case we call it the hydrogen ion, but sometimes it's -1, in which case we'll call it the hydride ion. You'll also note that the symbols in an ionic compound represent the formula unit, the lowest whole number ratio of ions that make the compound electrically neutral. We saw that calcium, for example, had a +2 charge. Fluoride has a -1, so we need 2 fluorides to neutralize the calcium. Here's an illustration of a crystalline lattice that shows the 1-to-1 ratio of sodium to chloride ions. On the other hand, if you look at something like calcium fluoride, you'll see a 2-to-1 ratio. In green, you see 4 calcium ions, but in red, you'll see at least 8 surrounding fluoride ions. The difference in the crystalline lattice will lead to a difference in the shape of the crystal on the macro scale. So let's do a little bit of practicing now. What compound is formed by sodium and bromine? First, identify your ions. Look on your periodic table and find sodium. It's in column 1, group 1, so they uniformly lose a single electron and become a +1 ion. We'll write it as Na+. Locate bromine on your periodic table. You'll find it in column 17. The halides in column 17 all gain a single electron and become a -1 ion. So bromide would be written Br-. If you put those 2 ions side by side, you now ask yourself, does that make a neutral formula? In other words, I have a +1 and a -1. That should add up to 0. Since it does, the formula unit for sodium bromide must be NaBr. And you'll notice that I've already said the name several times. It's sodium bromide. The name of sodium does not change. The ending of the negative bromine changes to bromide. You'll also notice that the cation, the positive, is written first in both the chemical formula and the chemical name. This is a universal rule. The name of the cation stays the same. The name of the anion changes slightly. In this case, bromine becomes bromide. What compound is formed by calcium and bromine? Let's go through the same steps. Find calcium on your periodic table. You'll find it in group 2, so it must have a +2 charge. So we'll write Ca with a little superscript 2+. Bromine stays bromide, so it's going to be Br- just like before. If you write those two ions side by side, you'll notice they do not add up to 0. This is not a good formula unit because we have to neutralize the charge. So the way we could do that is by having a 2-to-1 ratio. If we had another bromine, now we would have +2 and -2. That would be a good formula. To write it in shorthand, we write CaBr2, the subscript 2 showing there must be 2 bromines for every 1 calcium. The name of this compound would be calcium bromide. You do not have to tell the number of bromide ions. Anybody that knows calcium and bromine would be able to figure that out for themselves. Another example, what about aluminum and bromine? Aluminum is in group 13 on your periodic table. It should have a +3 charge. Bromine stays -1. Again, if you write them side by side, we notice this is not neutral. It does not add up to 0. We need another bromine and yet another bromine. We need a 3-to-1 ratio. So we can write AlBr subscript 3. But we'll call it aluminum bromide. Again, we do not have to give the number of bromide ions. Let's take on a few other ions and take a look at what happens to them. Magnesium is in column 2 on the periodic table. All the column 2 elements should be a +2 when they form an ion. Oxygen is a nonmetal, so it will gain electrons. It's in column 16. It should gain 2. If you write those two ions side by side, you get Mg2+, O2-. The +2 and the -2 do add up to 0, and so we need a 1-to-1 ratio. You don't write the 2's down in the formula. You write how many ions do you need. You need 1 magnesium, 1 oxygen, so the formula for magnesium oxide is MgO. And one more example. What about aluminum and oxygen? We already determined that aluminum has a +3 charge. Oxide has a -2 charge. If you write them side by side, you get +3 and -2. That adds up to a +1. We have too many positives. There's a missing electron somewhere. We can't change the charge on either of these ions. So if we need another negative, we have to write O2-. But now we have too many negatives. So we have to write another positive. But now we have too many positives. We have +6 and -4. So we have to write another negative. Now we should have +6 and -6, so our ratio must be 2 aluminum ions for every 3 oxygen ions. This compound would be called aluminum oxide. If you take another look at this, you might notice a little trick that you can use. Aluminum had a +3 charge, oxygen had a -2. The formula turned out to be Al2O3. Do you see it? If you take the 3 from the aluminum and put it as a subscript on oxygen, you take the 2 superscript on oxygen and make it a subscript on aluminum, you have derived the formula. We call this the crisscross method, and it generally works very well. The only exception is when both the charges can be divided by a common factor, such as if they're both +2, -2, +4, -2, then it doesn't. You have to figure out the ratio a different way. But it works especially well when one of the charges is odd and the other is even. Just a very quick review. This is not in your notes, but just watch the screen here. Binary ionic compounds. You write the cation first. That's the positive. Then the anion in both the formula and the name. The name of the cation is the same as the name of the element. K+ is potassium. The name of the anion changes to IDE. A few of them you have to drop a couple of syllables, like phosphorus becomes phosphide, but most of them you just change the very last 3 letters to IDE and it works pretty well. Put it all together, you have a compound called potassium chloride, KCl. You'll notice in the formula you do not write the charges. We use the charges to derive the formula, but once we have the formula, erase all the positives and negatives. Couple of examples. What would the formula be if an ionic compound formed between barium +2 and chloride -1? We have to neutralize the charge. In other words, the charges have to add up to 0. +2 and -1 does not add up to 0. But if we had another chloride, now we would have +2 and -2. So we need a 2-to-1 ratio. 1 barium for every 2 chlorides. So we write BaCl2. The name of this compound would be barium chloride. What about calcium and fluoride? Well, it's very similar to the previous example. We need a 2-to-1 ratio. Calcium fluoride would be CaF2. Strontium has a +2 charge. Nitride has a -3. If you put those two together, you get strontium nitride. And if you use the crisscross method, you'll derive the formula very easily. It's Sr3N2. Here's Chemistry Cat with a little chemistry joke. It's time to do some practice. If you haven't already done so, you need to complete Learning Check 1 in your notes. Then, the teacher should hand you Worksheet 9-1A, Binary Ionic Compound Names and Formulas. When you finish that worksheet, please turn it in to Dr. Kemp's inbox. You may also receive Worksheet 9-1B. If so, please complete it for homework and bring it back to class next time.